Hello everyone. Welcome to the sessions of programming in Python. In the last two classes, we had been extensively covering the concepts of OOPS, that's object-oriented programming. We had seen that how the objects are created. So basically, the objects are nothing but the examples of or the instances of class, a class which is a functional blueprint or an architecture through which we create the examples. And these examples or instances that we create, they are technically called as objects, and they inherit the attributes and the behaviors of the class from which they are being created. I know it might be quite confusing. Few of you might be having doubt. So this particular session basically focuses on uh, hands-on to see through the coding few more examples of how the object-oriented programming is used, how a class is created, how the objects are created out of it, and how we can practically um, use the class as an object in our day-to-day programming, right? So to start with, today we would be implementing the functionality of calculator, right? If you had not been using class as an object, then I'm pretty sure that you would have taken the approach like you would have created a module perhaps which goes by the name calculator. Okay, and in this particular file you might define a function which is doing, say, addition. You might as well define a function which does the subtraction. Okay, we might uh, have as well defined a function which goes by the name division, right, and a lot more. And whenever you were to utilize these functions, you would have individually called them, right? So this would have been our regular approach. But having learned the class as an object, then now let's see how we can create the class as an object and implement the same functionality here, right? So of course, there is no embargo that to implement any functionality, you necessarily have to use class as an object or you necessarily have to use function. It is your choice. Whichever concept you find comfortable with, you can implement your logic in it. But certain concepts definitely has plus points. They bring in the efficiency, they bring in the better readability, better security features, better uh, code segmentation, or the way you have structured code. So let's see how we can implement a concept of calculator here. Let me first create a class machine. Okay, why I'm creating the class machine? Because uh, I just want to also have one additional class so that we can also practice the concept of inheritance. All right, so I'm going to create a class machine, and within the machine class I'm going to define um, an attribute like manufactured manufactured in. Okay, so I'm going to store here uh, this machine is manufactured in which country. Perhaps I'll say Taiwan. Okay, so in this class, so any machine that is created, that inherits this class, that machine would, by default, is going to inherit this particular attribute, and it's going to be the value is going to be Taiwan. For example, when I'm creating a class, say oven, okay, and I inherit the class machine here, right? And let me write here init define init self, uh, maybe I'll write data. So build year refers to in which year it has been built. Okay, so here what I'm going to write is I'm going to create and now objects, examples. So oven It's a very small class. So the owen class or this template owen will help you create many owens, the objects. So let me write here owen1, okay, owen1, and I'm going to write here owen. So this is how you instantiate, trigger the build of that particular object. And since it is expecting some data with it, I'm going to write 2022. Okay, so this oven was built in 2022. And on the similar lines, I'm going to write here oven 2 as 2020. Okay, now if I try to print here oven 1, see, we should not ideally be printing like this, just this, because it is going to refer to a memory location, which is nothing but a junk data. Okay, because a class or an object, it doesn't have a shape or size. How is Python going to show you how does it look like? Yeah, it cannot. So it just gives you a memory location that at this place, of course, your object is created and it is stored here. But now if you really want to see the object, you should be seeing what attribute it is storing. So let me try to access what is the attribute of oven1 build year, and it's going to say 2022. On in a similar line, if I try to access here oven2 build here, you shall see that it is 2020, isn't it? Both are different. Why? Because while creating oven1, sorry, it is oven, that's my bad. Let me correct the spelling here. It's oven. Yeah. So it says different values, right? Because I have initialized them with different values when I triggered the build, or when I created these objects. Now, if I have now, you know that this oven, of course, this class oven is responsible for the creation of this oven1 and oven2. But however, this class itself is inheriting another class, that is machine. And when you are inheriting machine, that means any attribute that is defined here will also get inherited. So this is as good as you are defining something here. Okay, so if I try to access, let me let me try to print the manufactured in attribute of both the ovens, and you shall see that both of they say Taiwan, right? So this is basically the concept of inheritance. Okay, that was just a basic example of inheritance. Now let's, like I said, we are going to create the calculator concept. Now let me create the class calculator. Okay, let me also create an init. Okay, define, let me manufacturing place, and let me write here manufacturing year. Okay, and this is something I'm going to write. All right. So what you see here is I have created one superclass in which one data is fixed. When I say one data is fixed, that means this particular attribute I have defined at a global level. All right. So this particular, so whichever class I'm going to create and I'm going to inherit this particular class there, any object which is created, any amount of calculator that I create, all of those calculators, manufacturing place is going to be Taiwan. Okay. And however, this manufacturing year, this is something that is getting initialized every time you're going to create the object. Okay, so we'll have to provide the data ourselves. How to do? Let's go further and see. Okay, so now I'll have to write this particular constructor. So technically, this init function is called as constructor because this is responsible to initialize your object to the initial state. All right. So here I'm going to write self. Like I said, self refers to the that object which is under reference or which is under construction. All right. Okay. So here I'm going to write data, and okay, let me write here, just to avoid the confusion, let me write here uh, X. Okay. And here I'm going to write self dot brand. Okay. This is nothing but X, and I'm going to write self dot build material. Okay, I can write color, maybe color. Okay, which is y. So if I need another value, I'll have to write another value here. Okay, now you see here that if I have to create object, I'm going to write calculator 1. Okay, and here I'm going to write here calculator. What is the first value that I need? X refers to brand, so let me give here brand. Okay, y refers to the color, I'll write here black. Okay, okay, now remember that, of course, whether it is calculator 1, or let me create few more calculator. Okay, so you can say that one is your calculator, one is your friend's calculator. Okay, brand, I should not be writing brand, I should give some good brand. Maybe I can write here Samsung. Okay, and here I can write Casio. Okay, and here maybe I can write blue. Okay, so what's happening here is, here one calculator is being created through the calculator class, here another calculator is being created through the another class. Okay, you see this calculator class is inheriting the machine class, while your first calculator was under creation. This init constructor would initialize that corresponding calculator to the corresponding brand, right? And in a similar way, calculator 2 shall be initialized to this Casio and blue. But remember that this base class which is being inherited, that is also expecting certain initialization, manufacturing year, which should be coming from outside. So what we are going to do, we are going to provide another data, that is manufacturing year 2022, and here I'm going to write 2023 maybe. Okay, remember that, how do we see this particular initialization is automatically going to get triggered. Okay, when this calculator class is instantiated. But what about this base class? So we have, like I told you in the previous classes, we have two ways to also trigger the initialization of attribute which is defined in its base class. Okay, so this is called as derived class, this is called as base class. Or else you can also say this is the super class and this is the child class. So what are the two different ways? One way is, I can write a super, I can call the super method. So it's an inbuilt kind of function, dot double underscore init double underscore, and then I can write, okay, I should be writing another parameter, that is z, because one more data is coming here. This number is also coming, correct? Now I can send here z. Okay, so what's happening here is, when your each corresponding calculator is under initialization, the moment you the Python enters into this initialization, the base initialization also triggered. So this is one way to initialize. If we have to see print calculator 1 dot brand, let's see what do we get, and we get Samsung. Okay, in a similar way, if I try to write here calculator 2 dot brand, it is Casio, isn't it? Okay, now the next thing is, if I write here manufacturing here for both, you shall see that it says 2020 and 2023, isn't it? Now, this was one way to initialize your base class. Let me comment this out, and right below, let me show you what other way can be used. You can directly use the name of the class, and you can write dot init, okay, double underscore, and here. So remember that while you are using the super method to initialize the class, you can directly pass the data. But when you're using the name of the base class, then one more extra thing that you have to do is you have to write self here. You can memorize this, okay, and you have to write z. So this particular syntax and this particular syntax, they're doing the same job. It is just that these are two different styles to initialize your base class. Okay, now you can see that the same output I'm getting. Okay, so to avoid the confusion, let me remove one way, and we can just keep so much. Now, so far so good, isn't it? We have a base class which we are inheriting in the calculator class. This calculator class has its own attributes, and we are also initializing the calculator class, and within it we are also triggering the initialization of base class. Now the other thing that is remaining is so much so about the attributes. Now let's implement some functionalities. Okay, so when I say functionalities, the behavior, so what features and what behaviors do a calculator have? A calculator can do the addition, isn't it? A calculator can do subtraction or the multiplication, isn't it? So let's implement certain those behavior. Now I'm going to write define addition. Okay, let me just implement for two data. Okay, so here I'm going to write self, and I'm going to write maybe x comma y. Okay, it doesn't matter, these x and y and these x and y, they are two different things. Okay, these are just temporary variables which are created only for this particular method. And here I'm going to write return x plus y. Okay, in a similar way, the way I have written addition, I'm going to write define multiplication. Okay, and I'm going to write x multiplied by y. And in the same way, I'm going to write division. Okay, and I'm going to write here x divided by y. Okay, how do we use this? Well, just here I'm trying to print, right? Okay, so here I'm going to write calculator 1. Okay, let me remove all these things. Let me just print, or maybe I can store it in some variable, something like this, result. Okay, and here I'm going to call. So I have two calculator with myself, isn't it? So I will use calculator 1 at the moment. Calculator 1 dot addition. Okay, so addition, and here I'm going to pass 50 comma 10. So what I'm doing is I am utilizing the calculator 1. Okay, this is the object, right? And since this object has a method or a feature like addition, I'm going to call it. And now here I'm going to print result. And you see it says 60. And instead of addition, if I do multiplication, you're going to see the answer is 500, right? So this is what it is. And when it comes to encapsulation, that means preventing the outside environment or the outside world to access the data. You can also implement the concept of encapsulation. For example, if I write another method which is called as about. Okay, so this, what it is going to do is it is going to print uh, the brand name is self dot brand. Okay, I should always, whenever I have to use any internal variable, I should always do self dot like this I should write, because every time some calculator is trying to access this about, I need to refer that calculator's brand, right? So that is why I write self. So self keyword, this always refers to its own individual uh, attribute. Okay, and in the similar way, I can also print here shortly after. I can say print color. Color is self dot color. Okay, now what I can do here is I can just write calculator 1 dot about. Now what if I call this? You see, oh, there's an error. It says okay, but one was given. Okay, I should be writing self here, of course. Yeah. Okay, so now you can see, you see that it says it prints certain information, isn't it? The brand is Samsung, the color is black. If I, the same thing if I do with respect to the calculator 2, it is going to this particular method about of calculator 2 is going to get called. So these I mean these methods get associated with each object individually, right? Whichever you create. So this time calculator 2's about is going to be called, and when I call this particular about of calculator 2, it is going to do the same thing. The brand name is self dot brand, the color is self dot color, and this self is going to refer to this time calculator 2's brand and calculator 2's color. So if I run this, you see it says cashew and blue. The output is changed, right? Now, this was a simple example of how a base class is created, a derived class is created, and how you can create the objects using this class. Okay, and how you can access the individual attribute, or you can no, you can always call or invoke the methods associated with those objects. But apart from this, we have discussed the inheritance. Now coming to the encapsulation. Suppose I do not want the outside world to access this particular method. What I'm going to do is I'm going to I'm going to precede this particular function name with by double underscore. So when I put double underscore here, you will see that the access gets modified. The outside world do not have the access to this particular method any further. This is categorized into a private category. Earlier it was public. If I run this, it is going to throw me an error that it has no attribute about. All right. So why do we have the whole concept of classes and object? It's all because of such features of encapsulation that you have, the inheritance that you have. You don't have to reinvent the wheel time and again. If a larger code of logic which you want to write, which is proprietary to you, and you don't want to rewrite it again and again, maybe it is too large or complex, you can write it once, and you can always inherit the same piece of logic or code into the many further class that you may create. Okay, you don't have to replicate this code for each classes. You don't have to do that. You can just inherit it, so that all the attributes and all the functions and all the methodologies gets inherited in a single go. And if you put all these classes into a modules, you can also circulate around this module among your peers, your organizations, and the other Pythonians can use your file and use your class as an object to create their objects. Okay, so to also give you another relevance here. Okay, let me now remove this particular access modifier, and the moment I remove this from private to I make it to public, you immediately going to see the output here. Okay, apart from this, earlier we had been doing we would, if I were to create a list, I would create it like this, right? Either I'm going to create like this an empty list, or the other way that I had is to create like this, right? This is by this particular methodology I could create a list, right? Isn't it? Now remember that in Python everything is a object. Okay, the list is also an object, and this is like someone else has defined a class which goes by the name list, and that is why you are able to create a list. So when I print the data, you will see that an empty list is being printed, and the empty list is being printed. And when I print the data 2, also very next to it, again another empty list is going to be printed. All right, now what happens now is, what I want to tell you is that you would do something like this, right? If you have to add some values, append, isn't it? Say if I say 100, then 100 gets appended to this particular list, right? So if I print here data, and shortly after if I print data 2, you shall see that in data 2 100 has come. And just like this, if I write data 1 here and I write 500, you shall see that 500 goes into, okay. If I write here, okay, it's not data 1, it is just data. All right, yep. So you can see that individually 500 has gone to data, and for data 200 has gone. Now how come Python knew that 500 has to be stored in data and 100 has to be stored in data too? So remember, when I say append, this is a method. Okay, this is a method of data. So this append is happening on data only, and this append is acting on a data too. Okay, in fact I can initialize. So look at this. So what I'm doing here is, from the class list, I have initialized these two data. So list is a class. So just like list, there are many. You have something called as str. You have something called as dict. Okay. You have something called as integer. You have something called as tuple. Okay. List. So all these are different data types which you have learned earlier. You have a class for them. Okay. And you can always initialize using those classes. And when you initialize, these becomes the list object or dictionary objects accordingly, and individually on those individual objects you can always call their functions, methods, and these methods have different jobs to perform. Just like here we had calculator class and it had addition, multiplication, division, which were performing different job. In a similar context, Python has a inbuilt predefined the class like list which have these methods. All right, so this was one example. This is a class which we have created. These are the classes which Python has defined already, and within the class these are the append methods. You have insert, you have remove, you have pop, so many. Yep. So that was all about classes and object. It is one of the important concepts in Python, and it is widely adopted and used in the industry. Please walk through the notes that I have shared along with these sessions. I think we have covered 3 sessions with respect to classes and object, and the assignment I've shared. Any doubts, please connect to me individually. I would explain it in more detail and much depth with more examples if need be, if you get any doubts. All right. Thank you, everyone.